ଟିକେ ସାର୍ ମୁଁ ଥଙ୍ଗେଇଦେବି ଖେଳେ ନାହାନ୍ତି ଆଉ ଟିକେ ନେଟୱାର୍କ Good morning, all. Good morning. I'm just focusing to the board. Today we'll discuss the problems of a continuity. That is exercise 5.1. We'll discuss exercise 5.1. Yesterday, I had given you question number 1 to question number 25. Today, I will discuss your doubts. Now, you write the numbers required to discuss. I've already got good morning from you all. Good morning. Now you write the numbers required. From question number 1 to 25, you tell the question numbers. You write the question numbers in your live chat so that I will discuss the common doubts first. Common doubt first. Yes, question number 17, question number 23. I'm getting now the two questions. Question number 17 and question number 23. Yes, Prathi, 24. Those are having doubt, you tell now so that I will discuss the questions. First, I will discuss your doubts. Then, I will discuss some other questions. I will proceed from 26 onwards. Subhanshu, good morning. Yes, question number 9 also. Question number 9. Okay. Question number 9, 17, 23, 24. Okay. Anish. Hello. ଏବେ ମ୍ୟାଥ୍ କ୍ଲାସ୍ ଷ୍ଟାର୍ଟ ହେଲା ଲିଙ୍କ୍ ପଠେଇଛି ଦେଖିକି ଷ୍ଟାର୍ଟ କର Yes, 21C also, Saijoti. Okay, I will discuss all these problems first. 9, 17, 21C, then 23, then 24. I will discuss one by one. You see first the questions. Starting from the beginning, question number 9 first. Fx equal to question number 9 first. 9. Fx equal to x by modulus of x. X by modulus of x when x is less than 0. When x is less than 0 and minus 1 when x is greater than or equal to 0. This is the function. Our instruction is find all points of a discontinuity. Find all points of a discontinuity of f where f is defined by this one. First, we'll check left hand limit and right hand limit. Now, you see, actually, when x is greater than 0, this implies modulus of x is x. When x is less than 0, you know this thing, modulus of x is minus x. This is your definition of a modulus of x. Now, left hand limit x approaches to 0 minus fx. 0 minus means less than 0. This is the case. 0 x less than 0. So we write x by modulus of x. Now the result is limit x approaches to 0 minus x by minus x. Is it? When x approaches to 0 minus means less than 0, modulus of x is minus x. Modulus of x is minus x. So the place of modulus of x, I am putting minus x. Now the result is limit x approaches to 0 minus, here answer is coming minus 1. X cancel, it is coming minus 1. Hence the result is minus 1. Then right hand limit at x equal to 3, x equal to 0. Right hand limit is limit x approaches to 0 plus, limit x approaches to 0 plus fx. 0 plus means more than 0. When it is more than 0, it is given minus 1. So you write directly minus 1. So your answer is minus 1. Now left hand limit, right hand limit, both are equal. Minus 1 and minus 1. So limit exists and limit is equal to minus 1. Then calculate f of 0. So far as question is concerned, at 0, when x is equal to 0, in that case, fx is minus 1. Fx is minus 1 when x is 0. So this result is minus 1. Now fx, is continuous at x equal to 0. So far as values of modulus of x is concerned, if we consider left side of 0, it is x by modulus of x, that is minus 1. At 0, it is also minus 1. When x is greater than 0, that is also minus 1. So that you are getting fx equal minus 1, which is a constant function. Hence, it is a continuous function. It has no points of discontinuity. It has no point of discontinuity. It is continuous throughout, so it is a continuous function. This is a continuous function. Do you follow this thing? Now, question number 9. This is your answer. Wait, I'll proceed to question number 17. You write quickly so that I'll proceed to question number 17. Next question, question number 17. Whether it is now question number 17. Next I'll discuss question number 17. You write quickly this one. Now I'll proceed to question number 17. Still now some students are asking, sir, when class will start? As per timetable, already you know the timetable. Class starts from 8. Due to net problem or for arrangement, it may take 5-10 minutes sometimes. but our class start from 8 to 9. Now I'll proceed to question number 17. Question number 17. Find the relationship between A and B so that the function f defined by fx equal to a plus x, sorry, ax plus 1 if x is less than or equal to 3, and the result is bx plus 3 if x is greater than 3. And it is given the function is continuous at x equal to 3. At x equal to 3, at x equal to 3, at x equal to 3, this function is continuous given. Function given continuous means left hand limit equal to right hand limit equal to value of the function. Left limit equal to right hand limit equal to value of the function. Now we'll calculate left hand limit, then right hand limit, then value of the function, equate all the things. We'll get equations. Solving the equation or equations, we'll get a relationship between A and B. See now, left hand limit, that is the limit x approaches to 3 minus left hand limit at x equal to 3. Left hand limit is x approaches to 3 minus fx. When x approaches to 3 minus means x is less than 3. If x less than 3, fx is ax plus 1. So you write here ax plus 1. Now this result is, put now 3 here, put x 3 at x, if you put 3 here, then result is 3a plus 1. This is the value of left hand limit. Then right hand limit at x equal to 3. Limit x approaches to 3 plus our function is, when x is greater than 3, the function is bx plus 3. Now as it is an algebraic function, polynomial, bx plus 3, then put 3 here. So result is coming b into 3 means 3b plus 3. Then f3, when x is equal to 3, our fx is equal to ax plus 1. So you can write directly a into 3 plus 1, or it is same as 3a plus 1. Now we are getting left hand limit, right hand limit, and value of the function. As it is given in the question, it is a continuous function at x equal to 3. Then left hand limit equal to right hand limit equal to f3. You can write fx is continuous at x equal to 3. Fx is continuous at x equal to 3. That implies left hand limit equal to right hand limit equal to f of 3. Left hand limit equal to right hand limit equal to f3. Put the values. Left hand limit is 3a plus 1 equal to 3b plus 3 equal to again 3a plus 1. These two terms are same, not equal to take twice. Now you take this part and find the relationship between a and b. Taking this part, you'll get
3a minus 3b equal to 3 minus 1. If we take 3 common, a minus b equal to 2. Any one step you can write. Up to this, you can write this is also relation, this is also relation, or you may write a minus b equal to 2 by 3. This is your relation. Relationship between a and b. 3a minus 3b equal to 2 also you can write. From this step also you can conclude 3a minus 3b equal to 2. This is also your relation. This one also your final relation. You have to simplify this result. Now note down this one. I will proceed to question number 21C. 21C. Amrita joined. Yes, 9 completed. Saijati, proceed to 21. 21C you are doing now. Start 21C. Those have already given the doubts. 9, 17 completed. Now I'll proceed to 21C. I'll proceed to 21C. Once it is given continuous means, left hand limit equal to right hand limit equal to value of the function at that given point. The steps are very, very similar, almost same steps. Either you have to find the left hand limit, right hand limit, check whether equal or not equal, then value of the function. If given continuous, equate the steps. Now, you see question number 21. I am proceeding to question number 21C. In question number 21C, it is given fx equal to 21C. Fx equal to sin x into cos x. Sin x into cos x. Discuss the continuity of the following functions. 21C. Before discussing this 21C, one property there, algebra of limits. Algebra for limits, algebra for continuity. If f is a function, g is another function, both are continuous functions in their common domain. F continuous function, g continuous function, then our property says that sum f plus g is continuous, f minus g is also continuous, f into g is also continuous, and f by g is continuous provided g is not equal to 0. If g is not equal to 0, f continuous, g continuous, then f by g is also continuous. This is your algebra of limits. You know this thing in your standard 11. Now it is applicable for continuity also. In 12th class, in this class, if they are continuous functions, then f plus g continuous, f minus g continuous, f into g continuous, f by g if defined, it is also continuous, and it depends when g is not equal to 0. This is the restriction. Using this property, we can prove this one. Now, in one line, you can prove sin x is a continuous function. This one is a continuous function. Suppose gx equal to sin x. Another function you take hx, let it is cos x. Let gx equal to sin x, hx equal to cos x. Then you write it directly. Gx and hx both are continuous in the set of real numbers. These two are both are continuous functions. Both are continuous functions. Now, if both are continuous functions, then that implies gx into hx is continuous. Gx into hx is continuous. That implies fx equal to gx into hx, that is sin x into cos x is continuous. In theoretical, you can write here we are using the property that if two functions are given, then product of their result is also a continuous function. Product of two continuous function is also continuous. This is your property. You can follow this way and you can write by using properties. Otherwise, another way you can follow. This is your way. Another way. Another way also I'm writing. You see, for all the three bits, sum, product, quotient, difference, it can follow this one directly. Fx, it is given sin x into cos x. First you calculate, let A belongs to R. You can write for all A belongs to R. Don't write for all A belongs to R means A is any real number you take. Limit x approaches to A sin x into cos x. Then this result is coming sin A into cos A product. Sin A is defined for every real value of A, also a real number. It is a real number. It is a real number. So result is defined finitely. Now that implies you can write that fx you have obtained here limit x approaches to A, limit x approaches to A, fx you are getting f of A you can calculate directly, that is also sin A into cos A. Limiting value and value of the function both are equal. Now both the results are equal. Now limit x approaches to A, fx equal to fa, that implies fx, that is sin x into cos x, is continuous for all A belongs to R. R is the domain of this function. R is domain of this function. Now you note down this way also. Which one is better for you? You can write this one. This is your 21C. After completing 21C, I will proceed to question number 23. If 21C completed, you all proceed to question number 23. Now I will discuss that question. You try first. Question number 23. How can you write? I will tell you here. You try first. Question number 23. Next question. When I am assigning some problem, you do it. Suppose you have done yesterday or today morning. Again you repeat. Then we'll check where is the variation, which portion you have not written, then your mistake will be rectified. Question number 23. Here fx is given, fx given sin x by x when x is less than 0. It is given sin x by x if x is less than 0, and the result is x plus 1 if x is greater than equal to 0. This is the question. Find all points of discontinuity of f. See now, sin x by x if x is less than 0. X may be less than 0 or x may be greater than 0. It has two results. First, left hand limit. Left hand limit will calculate. Left hand limit means limit x approaches to 0 minus fx. 0 minus fx means we'll write this one when x less than 0. When x less than 0, fx is sin x by x. We'll write here sin x by x. You all know this formula. Limit x approaches to 0, sin x by x is 1. This result is known to you, it is 1. It is direct formula. You know, limit x approaches to 0, sin x by x is 1. Right, direct, right hand limit. Right hand limit. That right hand limit is result is
it unstable? Okay. When phone is coming, it became unstable. Unstable. Okay. I think it's okay. Subransu, is it okay now? Am I audible or not? Am I audible now or not? You see, if not audible, I should not continue. I will check. I think now it is stable. Okay, you see now. Right hand limit equal to, put now 0 here. Limit x approach to 0 plus, put x 0 here. If you put 0 here, your answer is 0 plus 1. Your answer is 1. Then f of 0. F of 0 means when x is equal to 0, x is equal to 0, then fx equal to x plus 1. So you can write 0 plus 1, it is also 1. Now, left hand limit, right hand limit, both equal to 1, means limit exists. And f0 is also 1. Now you conclude. Now, left hand limit equal to right hand limit equal to f of 0. This implies f is continuous at x equal to 0 first. At 0 it is completed. Now, what can you say about less than 0 and more than 0? Suppose this is your number line. Here is the point 0. At 0, we have proved here the function is continuous. From 0 to plus infinite, 0 to plus infinite, including also 0, your fx equal to x plus 1. X plus 1 is a polynomial function. Fx equal to x plus 1 is a polynomial function. Polynomial function is continuous everywhere. For every real value of x, it is continuous. It is a straight line. Its graph is a straight line. Y equal to x plus 1 is a straight line. It is a continuous function. From 0 to plus infinity, it is continuous. 0 to plus infinity, 0 to plus infinity,
it is continuous. Why? You write it is a polynomial function. All polynomial functions are continuous throughout the real number. This is the reason. Come back to left hand side. When x is less than 0, when x is less than 0, at that time, how can you prove this thing? You see, how can you prove this result? Most of the times, students are missing this fact. They are not discussing this function when it is less than 0. For all x less than 0, this is important. For all x less than 0, this part, fx equal to how much? Sin x by x. Let a be any negative real number. Negative real number. Any negative real number means a is smaller than 0. Now, if a is smaller than 0, then we write limit x approaches to a, fx is sin x by x. Now, what is the result here? Your result is sin a by a. A is not equal to 0. A is a negative number. So the result is sin a by a. This is your limit x approaches to a fx. We have got this result. Limit x approaches to a fx. Limit x approaches to a. At the time of writing, it may not be visible sometimes when I'm writing. Now see, limit x approaches to a fx, that is equal to limit x approaches to a sin x by x equal to sin a by a. Then what about your fa? fa is same. Put a here, you'll get sin a by a. Now limiting value is equal to value of the function. Now limit x approaches to a fx equal to f of a. This is x. This implies f is continuous on the interval minus infinity to a. Sorry, minus infinity to 0. I have taken one arbitrary number from 0 to minus infinity. Arbitrary number a is an arbitrary number from minus infinity to 0 means negative real number. For every real number less than 0, that limit fx equal to fa. Hence, it is continuous. Now we have proved here for any x lying from minus infinity to 0, this function is continuous here. At 0, it is continuous. From 0 to plus infinity, it is a polynomial function. Hence, it is continuous. Now, the given function is continuous everywhere. For every real number, it is continuous. So, it has no points of discontinuity. Question number 23. Our instruction is to find all points of discontinuity. It has no point of discontinuity. Everywhere it is continuous. Now we'll proceed to 24. 24. I'll proceed to question number 24. You write first the basic steps, after which you can proceed. You write after 24. I'll proceed 25 onwards, 26 onwards. I will discuss some important problems. Then you will do the remaining problems. Now attendance is very poor. 35 minutes completed. The number of participants is showing here only 15. It is very poor attendance. As 36 students, it is very poor attendance. You may not get time to read this thing. When school will reopen, only I will discuss problems from other books. I will not do these problems again. I will not discuss these problems. I will discuss the concept again and the problems from other books. I'll give very less emphasis to these problems. So now this is the best time to work out to all the problems and ask me the doubts. I will discuss. I think board is visible. I am not visible to you, but board is visible. So you should attend the classes. Now I'll proceed to question number 24. Exercise 5.1, question number 24. The exercise 5.1 is continuing. First exercise of the chapter. All the problems are based on continuous. Whether it is continuous or if continuous, find the value of A, B, C or K. Now question number 24. Determine if f defined by this is a continuous function. See now the function. Question number 24. Fx equal to x square sine 1 by x when x is not equal to 0. X square sine 1 by x and it is 0 when x is equal to 0. This is our question. We have to check whether it is continuous or it is not continuous. Start first how to calculate value of the function and limiting value of the function. Two things are required. Limiting value. Okay. Limit x approaches to 0. Here I am writing both the limits at a time. Why? Left hand side function is x square sine 1 by x. Right hand side also same function. Only when x is not equal to 0, fx equal to 0 given. For a left limit, right limit, for both the cases, when x approaches to 0 plus or 0 minus, function remains same. So not required to calculate left hand limit, right hand limit in this case. Limit x approaches to 0, fx means x square sine 1 by x. Limit x approaches to 0, x square sine 1 by x. Limit x approaches to 0, x square sine 1 by x, you can write this result as x square. Next step I am writing limit x approaches to 0, x square. Now tell me, what is the value of a sine 1 by x when x approaches to 0? For every value of x, if x is non-zero, if x is not 0 now, it is a number lying between -1 to +1. You all know range of sine theta. For every real value of theta, sine theta is lying between. You know this thing? Sine theta is lying between -1 and +1. Apply this concept here. It is a number sine 1 by x, a number lying between a number lying between -1 and 1. It is an oscillating number. It is an oscillating number varying from -1 to +1. This result sin 1 by x. You have to write it here. Then you put its initial value. Then you put its value. If you put here, it is not defined. Now the result is, as this is the case, x is not equal to 0. We will consider for finding its limit, we will proceed to 0 now. Now if you put 0 here, 0 into this result, what I have written here, a number lying between -1 and 1, your answer is coming now 0. And f of 0, it is given fx equal 0 when x is 0. If x 0, fx is also 0. It is 0. Now fx is continuous at x equal to 0. At 0, left hand side of 0, it is defined. Right hand side, it is also defined, and both are approaching to the 0 at x equal 0. So it is a continuous function throughout. fx is a continuous function. This is your question number 25. Note down quickly. I will proceed to question number 26 now. I will proceed to question number 26 now. You all read question 26 and proceed to 26 now. 26, then 30. I will discuss from my side question number 26 and 30. Your doubts are completed here. Those have been given, those have already asked. I have completed all your doubts. Now I will proceed to 26 and 30. I will discuss these two questions, 26 and 30. You try first 26. In that question, function is given continuous. That function is given continuous. You have to find the value of the given constant k. Find the value of k. Very simple question, but very, very important. So I'll discuss 26 and 30. Now our class is already 43 minutes. After 45 minutes, it may fluctuate. Sound may not clear or picture may not clear. Now I'm not getting any live chat. Are you present or not? Number showing only 15 students present. Only 15 present. Now, if I were add Arpita, it is 16. Here the names: Samikha, Kaustubh, Saijyoti, then Indira, Samikha, Om Prakash, then Puravi, then Subhanshu, Amit, Amrita. These names are showing the live chat. Okay, see now 26. Question number 26. Shortly, I'll complete. Very simple. 26 and 30 are very similar problems. In 26, we'll consider only 1 point. At 30, we'll consider 2 points. Here, the function is like this: 26 fx equal to k into k cos x by pi minus 2x when x is not equal to pi by 2, and it is 3 when x is equal to pi by 2. It is given to you. It is also given at x equal pi by 2, the function is continuous. At x equal to pi by 2, the function is continuous. Then find the value of k. Find the value or values of k for which the function is continuous at x equal to pi by 2. Now first you see its limiting value. Limit x approaches to pi by 2, k cos x by pi minus 2x. Now limit x approaches to pi by 2, k cos x by pi minus 2x. If x approaches to pi by 2, then you can write x minus pi by 2 approaches to 0. X approaches to pi by 2 implies x minus pi by 2 approaches to 0. If you take this is y, suppose, let y equal to x minus pi by 2. Then x minus pi by 2 approaches to 0 means this y approaches to 0. Now you are getting y approaches to 0. Now change the limit from variable x to variable y, so that the problem will be more easier to solve. So next step, I am writing limit y approaches to 0 when x approaches to pi by 2, at the time y approaches to 0. Then k cos x, if y equal to x minus pi by 2, then what is the value of x? X will be y plus pi by 2. Put here. In the place of x, write down y plus pi by 2. Here y plus pi by 2 by pi minus 2 into y plus pi by 2. This step is the most important step. Change the variable from x to y. You take y equal to x minus pi by 2. As x minus pi by 2 approaches to 0, y also approaches to 0. Now simplify. Limit y approaches to 0, k cos 90 plus theta, you know, minus sin theta, cos y plus pi by 2 will be minus sin y. So the result is minus sin y. This result. Cos y plus pi by 2 is minus sin y. Then calculate the denominator. Pi minus, if you multiply 2 inside, it is minus 2y. Multiplying here 2 inside, 2 cancel, it is minus pi. So plus pi minus pi cancel, it is minus 2y. Now minus cancel. The next step is k into k by 2 is a constant. K and 2 you write outside. Limit y approaches to 0, sin y by y. So the result is k by 2 into 1. Final answer of our limit is k by 2. K by 2. It is coming k by 2. Then what is the functional value? When x is pi by 3, fx is 3. Fx is 3. As the function is continuous, this limiting value is equal to value of the function. Then you write. Next step, I'm writing here. Fx is continuous at x equal to pi by 2. This implies limit x approaches to 3, limit x approaches to pi by 2, fx equal to f of pi by 2. At pi by 2, fx is 3. So f pi by 2. So next step is, this result is k by 2 and this result is 3. So this implies k equal to 6 is your final answer. K equal to 6. K equal to 6 is your answer. Now Your time is already 9. See now. Now the time is already 9. I conclude my class here. You try from 26 onwards, from 31, 32, 33, 31 onwards. Apply the concept composition of a two function, those are continuous, is also continuous. I mean, if fx is a continuous function, gx is another continuous function, f composite g is defined, then f composite g is also continuous. Composition of two continuous function is also continuous in their domain, common domain, if that is defined. Using that concept, fx equal to modulus of x or fx equal to modulus of sin x, you can prove. You take one is modulus of x, another is sin x. Okay, I will discuss all such problems next class. I will discuss your doubts. You work out problems from 26 onwards and examples. If any example left, see all the properties. Again, we will discuss tomorrow in my class. Now, thank you all. I expect you should give thank you in WhatsApp, not here. I expect thank you from your mobile.